Legacy IAS, another lecture of current affairs in science and tech. Okay, so again we have 5 topics. The first one is this Dhruv 64. Yeah, so this Dhruv 64 is India's first 64-bit processor that we have made. Now let's see this. Let's see the details of it. So first thing is, if you see here, why is this Dhruv 64 microprocessor currently in use? So this is India's first indigenous high performance processor. Okay, so it has 1 gigahertz of speed, 64-bit architecture, and it is dual core. Now where have you seen terms like this? You must have seen this when in some Intel chips. When you buy your laptops or computers, you might have seen terms like this: 64-bit, 1 gigahertz, dual core, quad core, correct? Octa core. So all these are what? These are terms related to these processor or chips. Now, understand. So this usually what we use in India, even for our personal use as well as what the government has to use till now, is mostly developed by foreign companies. Okay, for example, mainly AMR and Intel. So these are the two companies that mainly manufacture processors like this. Now, this CDAC, that is Center for Development of Advanced Computing, this is in India, Indian organization. This has developed this True 64. Now, it marks a shift from low-end controllers to strategic computing. Now, what does this mean? Low-end controllers. Now, see, you have learnt about in things. Now, in most of the devices in Internet of Things, what you have in them, what we called as embedded systems, those are mainly microcontrollers. Now, what is so microcontrollers? What do? They have very specific function. Okay, and they can perform this function very well, but they are very limited in that sense. So they will have very specific functions. For example, if you want to make a washing machine smart, then what you will do? You will have microcontrollers installed in that washing machine. Now, what functions it will have to do? What a washing machine does? 3-4 functions only, correct? Like you have to wash the clothes, then remove the water, then dry the clothes. 3-4, let's say 10 functions, not more than that. So this can be done very well by microcontrollers. Now, microcontrollers are usually 32-bit. Now, but if you are looking at more advanced use cases of these processor, then you have something called microprocessors. Now, microprocessors are usually 64-bit and they are more general purpose. That is, it can do a lot of different things. It can do a lot of different things. So this India has developed indigenously from at CDAC. This is for the first time that we have developed. Before that, we have had a series of different move forwards that we had taken eventually to reach this point. So that also we'll see, but this is the first proper microcontroller that we have developed in India. Understood? Now, so you understood. So now India is making a shift from low end controllers to strategic computing using microprocessors. Correct? Now, capable of supporting complex tasks, civilian as well as defense. As I told you, they can work as a more general purpose processors. Correct? So more complex tasks they can take. Whether it's civilian or defense does not matter. Now, let's move next. So now it says, what are the fundamental concepts behind these specifications? So let's understand them. First is microprocessor. Microprocessor is what? The brain or CPU on a single integrated system. So you know about CPUs. CPUs are there for a computer or a laptop, all these big devices. Now, for a single integrated single integrated circuit, for a single circuit, what you have are called microprocessors. Now they also have the new microprocessors that we are developing or that Intel has developed. Those are so powerful that they can do almost all the things that a normal computer can and even more. Okay, now 64-bit is data width, can process larger data chunks in one go. Now supports high RAM unlike 32-bit which is limited to 4 GB. So if some controller processor is of 32-bit, it is limited by 4 GB of RAM. But here it can support much higher RAM. Correct? Now next is dual core. So you might have heard of dual core, quad core. So all these cores are nothing but, you can understand them like number of brains that they have. So dual core is like two brains working together, and this leads to efficient multitasking. Understood? Mostly the normal controllers, normal processors that you hear about, those have single cores. Now we have developed dual core here. Those companies have developed even quad core and quadra core and all that. Now next, 1 gigahertz is clock speed, that is it can execute 1 billion cycles per second. Understood? 1 billion cycle means you can understand it like calculations, 1 billion calculations per second. Understood? Now, so these are the specifications of it. Now we move forward. What constitutes RISC-V architecture used in Dhruv 64? Now, what is this RISC-V? So see, this RISC-V, reduce instruction set computer 5. Now, full form is not important to you. What is this? So you know about Android? Correct? So Android is a system. Android is a system that can run on all smartphones or most smartphones. Correct? Apple does not use it, it's fine, but most smartphones are based on this Android. Correct? Similarly, we have something called RISC-V. This is same like you have Android for smartphones, for chips you have something called RISC-V. Understood? As Android is to smartphone is what RISC-V is to these chips or processors. Understood? Now see, so what is the difference? Now this Intel, okay, see ARM, Intel, so all these are companies that also make their own Android like systems or RISC-V like systems. Now but they have very high licensing fees and royalties on it. RISC-V is open source. So this is an open source standard like Android for chips. So Android is also open source. Then this is also an open source standard. So RISC-V is what our Dhruv 64 is based on. So it is not taking all this licensing or paying the royalties to these particular companies. It is using a open source system. Now what strategic advantage you get because of this? This prevents technology denial by foreign firms. Correct? Because open source softwares or open source systems are not controlled by any one entity, so nobody can deny you the access to them. Based on taking them as framework, you can build anything over it. Correct? You have many softwares that are open source. Correct? For example, all these systems that government has developed, DigiLocker, UPI, they have also made this open source so that anybody can build over it. That's why over UPI you have so many apps, Paytm, correct, PhonePe, all these are built over it. So similarly, those are called APIs. Here similar concept is there that this can be used by anybody. There is no licensing on it. Now this allows customization for space or defense needs. Why? Because we only are fabricating the chips, so we can change the manufacturing, change the fabrication a little, and then we can change the application. Then enables a fabless ecosystem, that is design locally and manufacture anywhere. You will understand this term fabless ecosystem in the next slide. Till here it is clear. Now next, now see, this is how India has reached to this indigenous processor. So it started, not started, but sort of the initial steps were Shakti 2018. This was IIT Madras. This was India's first indigenous RISC-V chip. This was the first chip that we made. Then Ajit in 2018. This was more robotics and industrial focus. Then we came to Vikram 2025. This was ISRO's space hardened navigation processor. So you are saying that right now whatever chips are being made here, they still have specific, very specific functions. Now then you have Tejas 64 in 2025. This is by CDAC. This has helped in industrial automation. Then you have this one, Dhruv 64. See, here it is written general purpose, high speed, commercially ready. So this is much more general purpose, much more advanced than all others before. Then future is these two names you can remember, Dhanush and Dhanush Plus. Here also you see Tejas 64. There was also Tejas 64 Plus. Both came in 2025 only. Then Dhruv 64 is the most important for us right now. This came recently, and then the future is Dhanush and Dhanush Plus. This will be the next generation of chips that we will make. Understood? Now, next. Now, what distinguishes fabless design from fabrication? Now understand these two terms. So fabless is what? Fabless is simply designing, not manufacturing. Now, let me tell you something about designs. So what happens when all these, you saw Intel, ARM, so all these companies, when they manufacture, when they make these chips, okay, so in their design only, they enter some elements which make them controlled. For example, one thing, that their GPU runs, for example in Intel, what happens, their GPU runs a particular code. Now this code is actually hidden from everybody, so nobody knows what this code does. First thing, if you put on that chip, is GPU runs some code, and then it gets to this processor part. So microprocessor comes later, and then it starts working or doing whatever work you have fed to it. That is fine. But what happens here is not known to anybody except the company. Now this is always a risk for all the countries, because we don't know that when they can switch it off, when they can change it, we don't know, because the initial setup only is not known to anybody. Understood? Now that is why even more than the manufacturing is just if somebody has designed the proper circuits and everything, which part will go where, everything has been designed properly. Now manufacturing is just putting this exactly in place as was designed. So main process is of design. Design is the main component. Once designing is done, then manufacturing can be done by anybody, and you can ensure that the manufacturing is according to the design. That's it. Then it is not that difficult. Now major issues created in the designing process itself. Now this, they have designed like this so that this code is not known to anybody. Correct? So this designing is a major issue. Now see how it solves this. Now see, so basically fabless is about design. Fabless, that is beyond fabrication labs. Fabrication labs are where these chips are made. Fabless is where designing is taking place. Now logic, architecture and IP are created by CDAC India. So this logic, architecture as well as IP, okay, are being created by CDAC India. So main, the brain part of it, how it will be designed, everything is being done by CDAC. Now Dhruv 64 is a design success. Understood? Now see, fabrication or foundry. Now fabrication is the physical manufacturing of the chip. Correct? So now, for now, most of the time we send it to different countries. For example, Malaysia has a big foundry lab. Okay, so we send all these designs to Malaysia or some other centers, and there it gets manufactured. but the main process is already done. Now whatever changes, let's say we want to make it make some changes according to our defense technologies, so we will make this change and then we will send it for manufacturing. So design we will be decided by CDAC. It is free of any royalties from all those big companies, and it will be much more secure for India. Now this is shift towards domestic prototyping. So now what they have started doing, so this SCL Mohali is the place where they started making some parts of Tejas. Okay, so Tejas they have made something. So fabrication lab now, but this is of limited capability. As of now this is limited capability. Over time we will develop our manufacturing capabilities also, but as I explained you, main thing is design that we are trying to get hold of first, which we are doing with this chip through 64. Now of course this is the first initial steps. As you saw, all those companies have gone very far ahead, okay, and we are still lacking behind, but this is a good step. Okay, so it's not that their use case will go away. They will be very important for us anyway. This is something that we are doing on our own. This is just baby steps. Then so what are the practical applications? So first is strategic sectors, secure communication devices, defense navigation systems. Okay. Then commercial sector, 5G network infrastructure, IoT, smart meters, home automation, automotive system. Basically, it's a very good kind of indigenously produced processor. So it can be used in many different ways. Not much. Then what is the government's policy framework? So this is Digital India Risk 5 program. Okay, this is Make India Global Risk 5 Hub. This is the aim of this program. Shift from technology consumer to technology creator. Just some fancy words. Then India Semiconductor Mission. Of course, these chips require semiconductors to be made. Then financial support for ecosystem development. Then implementation is being done by CDAC plus academia, IITs, startups, and all of these. Understood? So this is the policy framework. Main thing is knowing about that particular chip and some terms about how those processors, controllers, all those things that I explained. That's it. Now, next topic. Next topic is 21st century solution to snake bites. Now, this may seem like a very different article to you. This is from Hindu, 21st century solutions to snake bite. Now see, first let's see snake bites. So snake bite crisis in India, understand the magnitude of it. First thing is the neglected epidemic. So India records 58,000 deaths annually, highest in the world, because of snake bites. Then primary victims are farmers, laborers, and rural poor. Correct. Now, the big four limitation. Now, this part is talking about the issues in our current system of dealing with snake bites. So, the big four limitation. So, the anti venom targets mainly all the anti venoms that we have made in India. Anti venom, you understand? So, venom of snakes, to counter that, we make anti venom. You can understand it like some form of drugs. Now, anti venom targets only four species. These are called the big four. You learn in environment. This is cobra, rat, Russell viper, and saw-scaled viper. So these are the four main varieties. Most of the antivenom are about them only. This ignores 60 plus other venomous species and regional variants. So this is a major issue, correct? Mainly focused on these four only. Then even in this, regional variants are not being met by sufficient margin. So actually most of the antivenom that we have in India comes from a very small village community in Tamil Nadu. Most of it, almost 90% of it comes from this region only. Okay, so this community has been doing this for a long time, collecting venom from these snakes to eventually make antivenom. We'll understand the process. So now the issue is, now of course, all, let's say you pick even cobra only. So cobra, that is present in Tamil Nadu will be different from the cobras that we see in Uttarakhand, correct? So now they have genetic variations, but because it is coming from the same center all the time, that is why it does not even vary with the regional variants. So it is not that effective in some other variants. So this is also a issue. Then now see, systemic failures, late hospital referrals due to lack of transport in the deep villages, inadequate storage, cold chain issues in rural PHCs, public health centers. So basically cold chain issues are major issue because these antibodies or whatever antivenom we make, they need cold chain storage. Otherwise, they go bad. Okay, so they stop working. So that's why you need chain storage, and of course cold chain storage, making them available at places where it is needed, that is deep inside villages, that is very difficult. So these are the major issues that we have. Now let's understand the traditional or old method that we have been following since 1950s 60s. Now how it works, see, so what they do, first thing is venom collection. As I told you, that community or anybody does this. So milking snakes manually, laborious and risky. So you must have seen they take snake and they put it over a beaker like this, and then small droplets of its venom comes out. Okay, so that is the first part, that is venom collection. Then there is hyper immunization, so injecting controlled venom doses into horses. So then they do what, inject these doses into horses. Okay, now what will happen, biological response of the horse, not lethal doses, small doses, okay, into the horses. Now horse immune system creates antibodies to fight the venom, of course it will. Then fourth is harvesting and processing. So then they will do what, they will take blood out of horse or bleeding the horse, and then they are separating plasma from it, correct? Plasma they will remove, and through chemical purification they will eventually get to pure antibodies that the horse is producing. Now what they will do, eventually they will get to this heterologous serum that contains horse proteins as in horse antibodies to fight this particular venom. And but the issue will be that this will have very high allergy risk. So what is the process, they take the venom first, then they inject it in the horse produces antibodies, then they take their blood out. In that blood they take out the white blood cells or antibodies that are present there, correct? And those antibodies are used to make anti venom. Understood? So this is the traditional process, came in 1950s 60s, and still we are going on doing this, correct? Now this is of course not good, correct? Because first thing is, doing it with a doing something like this to a horse is not good, and of course this technique is too old. Now we have learned so many things, genetic engineering, this that, and still we have to use a horse. So this is not good. Now they have come up with a new tech. Now understand this. This was the news. How does the new genetic engineering technique work? Now this has been done by a group of scientists from Denmark. Now what they have come up with, see this. So first is specific immunization. So inject venom into camelid, that is llama or alpaca. Now llama, alpaca, these are camelid examples. Okay, camelid that are present in mainly South America. Now we also have different varieties of camels. Okay, we don't have this, does not matter, you understand the process. So first thing is they are injecting specific venom into this camelid. Then what will happen, genetic extraction. Then next thing will be same, their bodies will start producing antibodies. Now see, what they have found in particular varieties of camelid is isolate B cells. So whatever B cells they have, that is white blood cells that are that are produced, that are present in them to fight with this venom. So then they will do what? They will isolate the B cells and sequence the antibody DNA. You're understanding? There what they were doing? They were taking out the antibody itself. Correct? And because they were taking antibody, they had to take a lot of blood and then separate it, get the antibodies and make the vial. But here what they're doing? they are actually isolating the B cells or the white blood cells that actually manufactures this antibody DNA. Then they will do what? So white blood cells they have taken out. Then they will do what? They will do recombinant cloning. That is, they will insert this DNA code into bacteria or yeast via bacteriophage virus. So basically, there are viruses that can infect the bacterias or yeast. Now they will do what? In this virus DNA. So let's say this is the DNA of that virus. Now that antibody DNA that they got from that particular llama, they will remove this part of virus and they will enter this. Correct? So this is the antibody DNA. This is antibody DNA that is now present in this virus. Now when this virus infects this bacteria, now what will happen? This virus will start using all the parts of this bacteria to do transcription, translation, if you remember. Okay, so they will start doing all this transcription, translation, basically replicating inside the bacteria. So then you will have what? You will have many, like a very large quantity of this antibody will be made easily. So then they will do what? See this. Insert this DNA code into bacteria or yeast via bacteriophage virus. Then biofermentation. Bacteria act as factories in tanks. So bacteria can multiply quickly, and in that multiplication they can also produce more and more antibody DNA they already have. So they can produce more and more antibodies or nanobodies, as you will get to know. So this will mass produce pure nanobodies. So their antibodies are actually very, very small. That's why they're called something else, that is nanobodies. Very small they are. Now, so what you got? Just by replicating more and more bacteria, you eventually get to more and more quantity of nanobodies. Correct? Now, this is synthetic anti-venom or standardized, pure and cruelty-free anti-venom. Why? Because you are using this llama only to extract small amount of B cell. After that, the replication of this is being done in the bacteria. So you are actually not causing any harm to the animal again. So just small amount of B cells once you can take out from these animals, and then you can use it again and again to produce it in very large quantity. Any large quantity you can produce the same anti-venom. There what you had to do, because you were using the antibodies directly, so again and again you had to pluck blood out of it. So that was very cruel. This is not. This is exactly like, if you want to read, you can also read about insulin, how insulin is made. This is the exact same process. In that also they have identified that bacteria produces something like this, and then they use E. coli bacteria to get to a large quantity of insulin that is used to treat diabetes. Okay, so you can read about it, same process. Then next, why is the recombinant nanobody approach scientifically superior? Why it is superior? So size and penetration. So nanobodies are 10x smaller than horse antibodies, can penetrate deep tissues to neutralize venom rapidly. Correct? So this is first advantage. Then heat stability. See, they're thermostable, survives hot Indian summers without refrigeration. As we saw, one of the major issues that we had with the old method was of cold storage. This does not read cold storage. Then solve the cold storage chain problem in rural India. Then safety profile. No animal blood proteins involved. Correct? So it had very high risk, because along with those antibodies you will also get the proteins or everything that is being produced in the horse's blood. So that was very high risk. This is not that risky. Bacteria. So this is almost like having those pure nanobodies or pure anti-venom. So this is much better. Then next, what steps are being taken by the government? So and WHO or global bodies. So global goal is WHO roadmap 2030, target to reduce snake bite deaths and disability by 50%. Indian institutional support. So ICMR has developed a task force conducting national snake bite survey. Regional venom banks and all these are being created, promoting indigenization of diagnostics, then integration of snake bite treatment into Ayushman Bharat health packages. This has been suggested by central government. Central government has also suggested, or union government has also suggested state governments to include snake bites in notified diseases. Once they become notified diseases, what will happen? The state governments will have to constantly monitor their progress and how many people are getting those particular diseases from what. So everything has to be detailed. So that central government has said to state governments in 2024 that snake bite should be declared in notified diseases. Some states have done, some have not done. Anyway, next. Then we come to next, which is HAL's Dhruv NG. This is a helicopter. Now see, this is a very small part, very small article. So basically what happened? So this Dhruv NG is new generation Dhruv flight, a strategic milestone. Why this is a strategic milestone? So understand what is this first of all. So HAL is what? Hindustan Aeronautical Limited. So HAL enters civil aviation market, shifting beyond military forces. So HAL has entered civil aviation market. Now what will happen? So basically what they are doing, objective is to break the monopoly of foreign manufacturers, that is Bell, Airbus, etc. in India. Now target is to replace imported fleets by used by state governments and PSUs. Example ONGC. So their first target is that they will ask at least state governments and PSUs to stop using the foreign helicopters and instead start using our own. So first target is this only. Then significance, a major step for Atmanirbhar Bharat and high-tech transport. Understood? So this is simply a helicopter, nothing much that we have developed indigenously. HAL usually focused on developing things for military forces, all these helicopters or whatever. Now they are for the first time entering civil aviation market. Civil aviation as in these helicopters that they have made will be used in multi-purpose ways, apart from defense, in multi-purpose ways. Now, what are the key technical specifications? You need not remember the specification as such, not important at all. Just basic, class is 5.5 ton, type is twin engine, multi-role. Engine is powered by indigenous Shakti engines. This you can remember that it is powered by Shakti engines. Now, next thing, this has got CAT A performance or category A performance. This is critical safety standard for civil aviation. Now, CAT A performance means if one engine fails during takeoff or landing, the helicopter can still fly safely because it has twin engines. Correct? Then, capability designed for day, night and all weather operations. Understood? So, these are its capability. Now, last thing, what are the primary use cases for this? So, primary use cases will be first offshore operations, transporting personnel to oil rigs, for example ONGC over open seas requires category A. So that they have now gotten. Correct? ONGC has oil rigs deep inside the sea. Now they have to go there. Now how they can take it? So they can transport personals using the helicopters there. Correct? Every time they cannot take their ship and go. Mostly they have stationed all those ships there. And these transportation is done by these small helicopters or some small boats like this. Understood? So this can be done by the one that we have developed. Correct? Now next you have disaster management. So search and rescue during floods and cyclone can also be done using this helicopter. Then VVIP and corporate transport. As you understood, civilian work can also be done. So safe travel for state leaders and business heads can be done using this. Ultimately, it's the helicopter. Then law enforcement, aerial surveillance for police and paramilitary forces. So all these are its capability. As you can see, offshore operation, disaster management, VVIP, law enforcement, all these are civil applications. The Indian Army has much better helicopters already, but that we are not talking about. This is about civil aviation. Then this is it. Then we come to salvo launch of India's Pralay missile. Now see, so Pralay missile is what? Pralay missile is, this event was conducted by DRDO successfully. That is a salvo launch. Now salvo launches, that is launching one after the other. Okay, so as you can see, fired two missiles consecutively from the same mobile launcher. Now Pralay is a particular kind of missile. Correct. Now they have conducted some launch of it. Now objective is what? First, validates the ability to launch multiple attacks quickly. As you saw, this was fired two missile consecutively. Correct. So first thing is this context. Part of a rapid series of tests including Pinaka and K4 to modernize India's arsenal. So this is part of some larger mission that they are taking out to develop India's missiles much better. That is it. Very basic you need to know. This was why it was in news, because DRDO conducted this salvo launch. That's it. Nothing much. Then let's learn key technical things about Pralay missile. So this is a surface to surface short range ballistic missile. Surface to surface short range ballistic missile. Now range it has 150 kilometer to 500 kilometer. Now this is a very good intermediate range. Between what? So this bridges the gap between Pinaka rockets, those simple rockets that army has. Those have usually 70-kilometer range. Now and Prithvi missiles. Now Prithvi missiles can go thousands of kilometers. Correct. So this is somewhere in between. Correct. So this provides a good intermediate between both of them. Now engine is solid rocket motor. Now this is important. Solid rocket motor engine does what? So first of all, because it is solid and it is using rocket motor instead of jet engine, so what will happen? This can be very easily, very quickly deployed. It does not take much to deploy it. Very quickly they can be deployed and sent. Correct. That is why they are also called battlefield ready. So they are battlefield ready, these Pralay missiles. Now faster deployment than liquid fuel. Correct. Then payload is 500 to 1000 kg. So basically these are missiles. Now missiles can carry warlords. Correct. For example, they can even carry nuclear. Nothing. They can essentially, these are something that can carry some weight. Now they can carry nuclear also, they can carry anything. Okay. So now high explosives or fragmentation, all these are its advantages. Then how is its quasi-ballistic trajectory scientifically unique? Now, so this basically, even though you read here that it is a type of surface to surface short range ballistic missiles, so you might feel that it will follow this path. Correct. Like this, a path like this. Correct. Let's say from India to Pakistan. Let's say this is India, this is Pakistan. So it will follow a ballistic path. That is, it will be fired from here, then it will go through a projectile motion, eventually hitting Pakistan. Now, but it is not following actually this motion. Now it has something called quasi-ballistic trajectory. So basically it does not go that up in the sky. It goes just slightly up. Okay. And it is not like the earlier ballistic missiles where you have to just aim it from here itself, then you just fire them, then where they will go, you have no control over it. Here you do have control over it. So when you fire it, it can still change directions and it flies very low, so that radars are not easily intercepting it. Understood? So they are flying very low and eventually getting to Pakistan. So this is quasi-ballistic missiles. So depressed trajectory is the first thing. So flies much lower than standard ballistic missiles, that is hides below radar horizon, as you saw. Then maneuverability. Now in those, what we had to do, we had to aim from here and then it will follow the same trajectory. We cannot maneuver or change the directions. Here it has maneuverability capability. They have this capability, so they can change path mid-air and perform evasive maneuvers in the final phase. So in the final phase, when it is just about to hit its target, it can even do a lot of evasion maneuvers. That is to evade, let's say, because if they reach close enough, then of course people can see it and they will start attacking it. So it can do evasive maneuvers and then eventually hit the target. Then result extremely difficult for enemy air defense systems like S-400 to intercept. So this is Pralay missiles. Now, what is the strategic significance of this system? So tactical role, India's first dedicated conventional non-nuclear battlefield missile. So this is non-nuclear. Okay, I was just telling that you can take nuclear also to explain you the concept, but this is essentially a non-nuclear missile. Now see, this is India's first dedicated conventional battlefield missile. This is the most important thing. We have missiles that are much more powerful than this, but they will take time in deployment, and that you don't have in case of wars. So this is providing you the same ability or just little more time than those pinakas. Pinakas are simple missiles that we use for range of 70 kilometers. So just a few minutes more than pinakas, and then they can cause much more destruction than the simple rockets. Now, designed to destroy enemy bunkers, radar sites, and command centers. Correct. Then China counter. So balances China's Dongfeng 12. This has similar capabilities. They also have one of theirs. Then capable of deployment in high altitude borders. Example, Ladakh, Arunachal, all these. Okay. High altitude test was also done for this Prelims missiles. That was in news, I think, in July, August. Okay. In Ladakh, they carried out the test. Okay. Then we come to last topic, that is government bans nimesulide tablets. So this was very much in news. Very common medicine, nimesulide. You might have taken this by the name of Nimesulide, by the name of Nice. All these are examples of this only. Now see. So what has government done? So first understand the ban. Just read the ban carefully. What it says: government has prohibited the manufacture and sale of immediate release nimesulide oral formulations above 100 mg. Okay. See this term: immediate release nimesulide oral formulations above 100 mg. So first of all, a blanket statement like government has banned nimesulide drug in all its form. Is this correct? Absolutely no. Correct. Now see, how many specific things are there? So first thing, the name, that is they're banning this particular drug nimesulide. Now in what? In oral formulations. Now not all oral formulations, only which are above 100 mg, that is banned. Now not even these three being met is enough. It must be in the immediate release form. So there are different kinds of release in drugs. So some are they release very slowly, so that is different. Some release in some different ways. Okay, so those are all different. When it is immediate release, that is you just take this and this immediately releases all the dosage, this particular thing is banned. Understood? Nimesulide oral formulation greater than 100 mg and in immediate release form, this has been banned. Now context: January 2026 status, latest move to restrict adult dosage. Now past bans. So in 2011 they were banned for children below 12 years. Correct? This particular drug. Then in 2025 it was banned for veterinary use also to save vultures. So vultures were having diseases caused by this, because all these animals were taking it, and then vultures usually eat these animals when they die, so they were getting diseases because of it. Okay, so it was banned for the veterinary. Now at last government thought that we should ban this for adult humans also, because of course children are more important, and then comes the veterinary animals, and eventually eventually comes us, that is the adults in this country. So now they have put a ban for us also, but here there are many limitations, as you understood. Now why it was banned? So what is the scientific basis for banning high dosage of this drug? So first is hepatotoxicity. Hepatotoxicity, so basically it can cause liver damage. So nimesulide, okay, creates toxic metabolites that attack liver cells. So first thing is liver damage. For us only thing matters, this causes liver damage. Then causes oxidative stress or damages mitochondria, leading to cell death. So it affects our liver and mitochondria. That is all you need to remember. Then risk is what? It can trigger fulminant hepatic failure. Again, name is not important. What is important? It can cause sudden liver failure. As we already understood, damage our liver even after short term use. Now availability. Now see, whatever it was doing. So actually what it does, it is mainly a antipyretic, that is बुखार उतारने के काम आता है. Okay, if your temperature is very high, then it reduces your temperature. Okay, one thing is this. Other thing is it is a painkiller. Nice, you might have heard. Okay, nice tablets. Okay, so those are actually the same thing. They also have nimesulide. Now those are painkillers. So these are the two main uses of it. One is antipyretic and other is pain relieving. Okay, so now safer alternatives are available for both of these. For example, paracetamol also does this, correct? Ibuprofen also does this. So that is why they are saying that we can literally ban this drug over a particular quantity and it will be fine. Then under which legal framework was this decision made? So this was made under Drugs and Cosmetic Act 1940 under section 26A, which gives central government power to ban drug if. Who has this power? Central government has this under Drugs and Cosmetic Act 1940. First thing, it involves risk to human beings or animals, then they can ban it. It lacks therapeutic justification. It lacks therapeutic justification. Safer alternatives are available. Now, so second is कुछ वो कर नहीं रहा है, it is not working well, it does not have any therapeutic justification to be given, and the third is safer alternatives are available. As you saw, all three were ticking in case of this nimesulide, and that's why they banned. Then how is this ban different from previous FDC bans? Now understand this. So there is something called fixed dose combinations. So you must have seen, whenever you buy some medicine, if you turn it over, you will find that, for example, let's take levocetrazine. Okay, you might have this by the name of L-Montas. Okay, so now this levocetrazine, now this is used for when you get common cough and cold. Okay, this medicine can be taken. Now if you look at the back of it, it has 10 mg of some liver, some medicine, and the other 5 mg is actually cetrazine. So this is cetrazine and this is something with L. Now so these are the two major drug components. Now they have somehow got this, that if we combine both of these, then we can get more efficacy. So that's why they combined it, made it a single medicine, and then people started having this. This is called fixed dose. Government keeps banning them. Why? Because somebody would think, some pharmacy, not pharmacy, some manufacturer will think that if these two are mixed in their own lab, certain tests they will do, and then some, and then they will start selling it, correct? Of course there are some regulatory mechanisms, but after that they start selling it. Now if the government finds that this is just irrational, for no reason they are mixing these two drugs, or it can cause some harm, so then they would ban this. So most bans actually target FDCs. Okay, now, but this ban is special because it targets the single molecule, that is nimesulide itself, in high dosage. Understood? So this is not like banning Almontes because it's a useless medicine. It is actually banning citrazine because citrazine is a molecule. So here they are banning molecule which is rare. Then significance signals stricter scrutiny on legacy drugs. Older drugs approved years ago, but now found unsafe. So when it was approved, of course, they must have tested at that time also, but it was approved like tens years ago, many decades ago. So then they might not have that capability that they have now. So now if they are seeing that this is not working well or it is unsafe, there are alternatives available, so then they will ban it. So this is a good thing that the government has done. Then the last thing that we come to is pharmaceutical regulation in India. This was not directly in news, but I think this is important for you to know. Okay, students get very confused with this, so this I have created. Now see how pharmaceutical regulation takes place in India, that we'll understand. First thing is approval. So now see, this is done by authority, that is CDSCO, Central Drug Authority. Okay, now this does what? This is under Ministry of Health and Family Welfare. This first of all approves new drugs. Whatever new drugs have to come has to be approved by CDSCO. Then it clears clinical trials for them. Then it controls drug imports. Whatever drug you are importing, that are also, if you're importing some drugs, they will also test those drugs. So approval is entirely carried out by this CDSCO. This is under Ministry of Health. Then step 2 is production. Production will be done in factories and labs. Now the here authority is of state drug controllers. This is under state government. It licenses manufacturing plants. Then it enforces revised schedule M or GMP standards. GMP standards are global medicine practices, something like this. So basically it gives the standards based on which any medicine needs to be manufactured. So they enforce these standards and they conduct factory inspections. So basically production part will be dealt by state drug controllers. Okay, people think they know only one organization. If they know CDSCO pharmaceutical सब वो करता है. It is not true. It is also very confusing. Now once the production is done, now see the third step, that is pricing. Now pricing is actually done by something called NPPA. Okay, National Pharmaceutical Pricing Authority. National Pharmaceutical Pricing Authority. Now the interesting thing is this comes under Ministry of Chemicals and Fertilizers, not Ministry of Health. It is a probable question also that this is under Ministry of Chemical and Fertilizers, and this manages the pricing. So what should be the fixes ceiling prices for all these medicines for scheduled drugs under DPCO. Now scheduled drugs are drugs which are declared essential under Drugs and Cosmetics Act, under this particular order of under the act. So under this order they have schedule 1. So here they have something called schedule 1. Schedule 1 medicines are called scheduled medicines, and what medicines are put here? Only essential medicines which are very essential, those are put here. So for essential medicines it fixes ceiling prices, because otherwise what will these people do, manufacturers? They will quote unnecessary high prices. So for essential medicines they regulate the prices, not for all medicines. Then monitors price increases, correct? Then recovers overcharges. Now sometimes let's say they have fixed a ceiling price for a particular drug, correct, that it cannot go beyond it. Now some manufacturers are selling it, then what will happen? Then they will recover the overcharges that they have gotten. So they will also put penalty on them and recover the overcharges. Then, so this is under Ministry of Chemical and Fertilizers. Please remember. Then, next comes distribution. This is again by state drug control departments. So they will license retail and wholesale drug outlets, all those medical shops and all. So those are licensed by these state drug control departments. Then conducts market sampling, enforces distribution norms. All these are developed by them. Then last, see, safety and ethics. So this is actually managed directly by the ministry. So it is managed directly by Ministry of Health and Family Welfare. This is based on a recommendation of certain technical committees that are there for drugs and CDSCO. So CDSCO and these technical committees recommend something that this should be banned, this should be regulated like this. For example, all these technical details will be given by technical committees. That's why they have such specific ban, greater than 100 mg in immediate release form. Ministry won't be doing this, correct? So these committees suggest it. Then, but who is banning it? Ministry is banning it. So see, bans unsafe or irrational drugs under 26A of Drugs and Cosmetic Act 1940, correct? Then issues safety directions and ensures ethical drug use. So safety and ethics is managed by the ministry itself. Understood? So there are so many different organizations. First was CDSCO, that is managing the approval. This is under Ministry of Health. Then you have state drug controllers, that is managing production. Then pricing is managed by NPPA, that is under Ministry of Chemicals and Fertilizers. Then distribution again by state authorities. And fifth, that is banning and regulating the ethical use of these drugs is managed by the Ministry of Health itself. Understood? Okay, so that is it. That is it for this one. You have reached the end of the document. Thank you.